Hello and welcome. This is a separate series of lectures uh, exploring the last item of the second free lecture, which is the examples of uh, delay analysis tricky cases. I thought if we are going to go to do this, it's better to spend some time or invest some time explaining the structure that I'm going to follow and explaining the methods we are implementing for delay analysis in these mentioned examples. So I will just invest actually, not spend. I'm going to invest 10 to 15 minutes explaining where I'm coming from in relation to the categorization of the delay analysis methods, so that when I go to the example, you know exactly what I'm talking about. I know most of you worked in some kind of examples related to this delay analysis things. However, I'm going to follow a certain method following the RP2903, which I prefer. As I mentioned, and as most of you know, that there is a major reference coming from the Association of Advancement of Cost Engineers called the Recommended Practices, RPs. In the delay analysis, we have two recommended practices, RP 5206 concerning the prospective analysis, and RP 29 RO3 concerning the retrospective analysis. So I'm going to follow this in the example. However, we have another respectable and major reference called the Society of Construction Law Delay and Disruption Protocol, Society of Construction Law, SCL, Delay and Disruption Protocol, which was well known and still actually well known and has been recognized for decades as the major reference of implementing the extension of time claims or the analysis or implementing the delay analysis method in extension of time claims, and actually is still being implemented widely. And I have to mention that before I started knowing the recommended practices, either one, I used to understand or used to know, as most of my colleagues who are dealing with the same cases, that the SCL is the only reference. And at a certain point, and the funny thing that before this, at a certain point, I was convinced that window analysis is the only method to analyze or to do the delay analysis. Anyways, let's just invest our time wisely. We will just skim through some related delay analysis method. Following the RP, I'm going to, and at the end, I'm going to correlate between both. So this is part of a training related to delay analysis for construction projects. And the item is delay analysis method categorization in accordance with training content. In the RP to recommended practices, the Association for Advancement of Cost Engineers, the categorization goes by layer. So the first layer is related to timing, which is concerning about the event, not anything else. If the event is in the future, so if an owner or an employer comes to the contractor and asks him to do a certain variation order or additional scope that will happen according to the schedule or will take place according to the schedule later on, not now. So if I'm going to tell you I need another connection point to the tie-in point for the building, or I'm going to revise the mountable partitions to demountable partitions, and I'm at the stage of excavation. So this variation is going to come later on. So the event is prospective, which comes in the future. So most of the measures implemented to the fragnet, which is the representation, the network that represents the delay analysis, the delay event, are estimated. So we are following estimations. Most probably best guess estimations. However, still in the future, and still we cannot rely on as retrospective, or the other one as actual records. These are still future estimated records, and will happen in the future, and even the impact, and consequently the impact of these events is going to be also prospective in the future. So the event is 100% or less, or 90%, not far less, 90%, 95%, 100% prospective, and consequently, of course, the impact is also prospective. So it's going to impact certain activities inside the project, inside the project schedule, and these events have not yet commenced. The other one, or the other timing, is the retrospective methods. The retrospective methods are those methods which are relying on events that already occurred and has actual records. So if we have events that occurred, finished, or mostly occurred, 90% finished, or 95% finished, or 80% finished, I'm not giving standard percentages. I'm just giving some of you examples so that you can feel the number. Whatever we face this case, then we will go for the retrospective analysis. The timing is categorizing the implementation to either prospective, which contains only one method, or retrospective, which contains 9 different major methods. If we can slice and dice between these methods, we will go to more than 60-something methods. But anyways, the prospective is one method, which is the time impact analysis, and there is a separate recommended practice for the prospective analysis called the RP 5206, and this is the major time impact analysis. And in some professional communities, when you say time impact analysis, the community, or the professional community, or those who are working in data analysis in this professional community will understand that you are talking about prospective analysis. The retrospective analysis is different. We have multiple methods, and this will go to another layer of categorization in the coming slides, and by which we are going to choose our methods that will come in our 5 examples. These are the layers. It's a bit complicated, but it's not that complicated. So if you see here that we have the timing, this is the retrospective, not the prospective. So we'll go to another level of categorization. We have, and of course, I'm not going to go into details. I'm going just to go to highlight what I'm explaining in terms of categorization of the retrospective methods. I'm not going to go into details, just to manage your expectations. I'm going just to highlight so that when I start explaining the examples, you understand that I'm following, or I'm at this certain layer. So we have layer 1, the timing; layer 2, the basic method; layer 3, specific method; layer 4, the basic implementation. And out of respect to all other references, the RP highlighted another layer. It's not a layer, it's something called the common name. The common name. Layer 5 is the fixed period versus variable periods. Layer 5 is this one, global insertion versus stepped insertion. We will come to this, but the last line in this table is highlighting the common name, or the market name, for each layer, for each activity, so for each method. So if we are going to say that we are doing retrospective, observational, dynamic method, contemporaneous as is, or modified, then we'll go and say, and this can be called also Windows analysis. That's how it goes. So this is the start point. I'm going to pause here, save this video as video number 1, and in video number 2 we'll see it in a better shape, in a better organized shape. It will be this slide, which goes by layer and names every layer, and then we'll understand what's MIP mean, and then we'll know what is the correlation and how can we correlate between the Association for Advanced Cost Engineering reference and the other reference, which is the SCL delay and disruption protocol. So We will stop here for this video, and just to maintain that the video is short, and we will continue the categorization in the next video.